This week on Slo Mo, we're filming the hottest thing on the planet.
Lightning. So today we're here with Chris Stone from the Morgan Botti Lightning Lab.
And you've basically got the keys to the world's most powerful weapon.
Well, one of them. We produce simulated lightning here.
In order to create our artificial lightning in the chamber, the first thing we're going to need is this bank of capacitors. Now these could generate 60,000 volts at 100,000 amps. These then travel through the back here, and then goes up and then back down through these resistors, along these cables, and finally into this room where we'll get the arc. Because of the dangerous nature of what we're going to be filming today, we need to remotely trigger the cameras. So we're going to be doing that from the safety of the bunker on the other side of the lab, and everything that will be coming from the camera to the bunker will be via fibre optic cables to prevent any unnecessary current travelling along through there.
3, 2, 1.
That was a good one.
Oh, hey, wow. So because we've got such a heavy filter on, we're only like to see the arc itself.
And it'll probably be in one frame.
Which is 20 microseconds.
Yes. You can see the arc itself is only a centimetre in diameter.
You might be able to hear the thunder, but what you probably can't see or feel is the shockwave. We can feel it over there in the control room, which is miles away. So we're going to try and visualise that with candles.
When the arc is formed, the air is heated up so much that it's got to expand. So that creates the
shockwave.
Yeah. 3, 2, 1.
There go the flames.
Whoa!
God, that's so light.
Well, it looks like it blew them out instantly there. So that shows that they don't go out as soon as the arc hits.
That's right.
These are off the surface completely.
Lifting slow. Yeah. Slowly lifting.
There seems to be all sorts of colours going on in there.
Yeah, I wasn't expecting that.
It ionises the air, so when it does that, it releases different gases, plasma. Well, the lightning strike, the impulse is 20 microseconds.
Whoa.
So the whole thing is over in 150 microseconds.
So we filmed these shots at 30,000 frames per second.
Which is way faster than we've gone before.
So that's 1,200 times faster than conventional speeds. We are recording a second of real time. Now if we were to watch that back, it would take about 20 minutes to watch the whole thing. So that's showing us quite how quick this action is, that over a few frames those candles are completely blown out by that shockwave.
That's nuts, isn't it? So to be honest, that looks really awesome, but I'd love to see the sort of impact and power that lightning can have on more earthbound things. So if we can try and strike a tree, that would be absolutely incredible, but I think we might have to scale it down a bit.
There we go, little friend. Well, I think we can definitely prove that sitting under a tree in a lightning storm is going to be a bad idea.
Absolutely, yeah. And Mini Sam goes underneath to be our little test subject, and then we'll see what a lightning striking a tree actually looks like. It's almost an impossible shot to get in the wild. 3, 2, 1, fire in the hole! Hey! That's pretty crazy. This is basically all the remains of that bonsai tree, which is quite extraordinary. I mean, that is 100,000 amps, give or take, and there's about 56,000 volts that was driving it through. It's a very small area, so it's actually very similar to lightning, if not quite powerful for lightning. And it shows just how destructive that is. So that is why you don't sit under a tree in a lightning storm. It's pretty terrifying, actually.
I can't resist having one more go and try to get an even bigger lightning explosion.
And if you think that was as awesome as I thought it was, remember to subscribe to Earth Unplugged, and we'll see you next time on Slo Mo.